Next, we're going to talk about free response questions from the section. There's two problems here to practice. For this question, part A, find g prime of x. So we know that g is the integral from -3 to 2x minus 1 of f of t dt. And this is just like the other problems we've done from the packet. To take the derivative of the integral, I need to do f of 2x minus 1 times the derivative of 2x minus 1, which is 2. I'll just write that 2 times f of 2x minus 1. And that's it for part A. If we don't have an equation for f, that's as far as we can go for that. But moving on to part B, didn't realize I was under highlighter. For part B, we're looking for g prime of 3. And we can do this. We can plug 3 in for x, so 2 times f of 2 times 3 minus 1. So I'm going to have 2 times f of 5. If we look at the graph, f of 5, so this is the graph of f of 5, this is the point 5, 1. So we're just going to get 2. And last question, for part C. So now we have something different. H is the integral from -3 to x of f of t dt. So we want to know where h has a minimum. So we remember to find a minimum, any minimum occurs when the derivative, sorry, I shouldn't have used f. The min will occur if h prime changes from negative to positive. So if we know that h is the integral of f, then we know that the derivative of h is f. What that means, if we have the graph of f, like I said before, this is the graph of f, so we're looking at the derivative. So where does this graph pass from negative to positive? Well, it does that when x is 0. So h has a min when x is 0. And the justification, because it says we have to justify, this whole thing here, that's our justification, the part that I wrote before. For the next problem, we need, so now we have the graph of f, remember that's f, and g is the integral of f. So first, part A, I want to find g prime of 1. So if g is the integral of f, then g prime is f of x. So we're looking at the derivative. If I want to find g prime of 1, I'm looking for f of 1. F of 1 is this point here, f of 1 is 0. So g prime of 1 equals 0. And part B, point of inflection. So we need to remember that we're looking at the derivative. And this is a bit of a throwback, but if we're looking at the derivative, g has a point of inflection wherever its derivative has a max or a min value. For this, we're going to ignore endpoints because this is an open interval. It doesn't include -2 or 8, it's just the values in between. So we look in between, we look at our graph and we look for mins and maxes. I have 1 min and 1 max. So we have where x is 2 and 6 as our answer for that. For part C, average rate of change. So average rate of change, this is an old formula, might have been from chapter 2. But the average rate of change is the change in y over the change in x. That means I need to find g of 8 minus g of 2 over 8 minus 2. And this part it's a little bit of a mess finding g of 8 and g of 2. To do that, this is more of a question for the next video. So if you don't follow this, I'm going to go into it a little bit more detail in the next notepad. But g of 8, so we know that g of x is the integral from -2 to x of f of t dt. So g of 8, I would plug in 8 for x. So now we need to look at this, and this is something from before break. The integral from -2 to 8 of f of t dt, I can look at this in terms of area. So if we go and if we look at our graph, and if we think that we need to find the area between -2 and 8, we need the area of all this space. So that's another way to evaluate an integral that we talked about before break. If we find that area, so we have 3 triangles, don't forget that this triangle here is below the x-axis, so it's negative area. But this ends up being 9/2 as the area for that space. We would find g of 2 in a similar way. So g of 2 would be the area between -2 and 2. So if I go between -2 and 2, so now I have these triangles, keeping in mind that one's negative and one's positive. When we do that, we get 3/2. So we need to do all this work just to find g of 8 and g of 2. And again, we're going to do a little bit more of this in the next notepad. But to find the average rate of change, we need the difference in y over difference in x. So the difference in y is 9/2 minus 3/2 over 8 minus 2 is 6. 9/2 minus 3/2 is 3/2. Sorry, 6/2, which is 3. The final answer is 1/2. The last question requires this answer. So for part D, for how many values of C is G prime equal to this number? So for how many points is this true? Is the derivative equal to 1/2? Well, keep in mind that G prime of X is the graph we're looking at. So G prime of X is f of X. So the question is, how many points is f of X equal to 1/2? 1/2 is somewhere about here. And we're looking just on the interval 2 to 8. So 2 to 8. So the question is, how many times is f of X equal to 1/2? Twice. Somewhere around these 2 points here. So for how many values of C, I shouldn't have said just twice. I should say f of x equals 1/2 for 2 values. And that's it. This last part, part C and D, we'll do a little bit more in the next packet. But please reach out if you have questions, and there are a couple of extra practice problems to try online.